Hello ladies and gentlemen, welcome to Unit 5 review, page number 3. We're going to start off with number 23. Sophia deposits $350 into a savings account, yada yada yada. I can go through the whole explanation, but more specifically I'm going to take a look at this part where it says compounded monthly. Once you see that part, talking about the way that's compounded, we're going to be working with this specific formula. The amount is equal to principal times 1 plus the rate over n to the nt. Now this formula will be given to you on a test, so you just need to make sure that you know where all the specific parts are coming from. The principal, which is also known as the initial amount, which is 350. The R, which should be the interest rate, we write that actually as a decimal, so 0.032. The N value, which means how many times it's compounded in a year, so since they say monthly, that's going to be 12. And then the time, which is going to be 4 years. Plug all those values into your equation, so the amount is equal to 350 times 1 plus 0.032 over 12 to the 12 times 4. Now the big important thing that you need to remember here is when you're typing all those things into your calculator, make sure that 12 times 4 is in parentheses when you do the caret symbol. And then you should be able to get your value. Your value is 397.726. Since we're talking about money, we want to make sure that we round up to near cent, so it's going to be 73 cents. So $397.73. Number 24. Awesome Town, right next to Awesomeville, has a population of 12,000. Every 3 months, the population of Awesome Town doubles. So this is not using the previous equation to help us write an exponential rule, but we're just going to have to write it based upon the information that they give you. So what I do is I start off with some type of amount or population. So the population that we start with is 12,000. Next, it says it doubles. So when I think about doubling, I think about multiplying by 2. But it just doesn't multiply every month, because then I would say 2 to the t power. It multiplies every 3 months. So instead of writing just 2 to the t, for representing every 3 months, we're going to divide that by 3. So it is 12,000 times 2 to the t divided by 3. And that's my equation. Part B. What will the population be after 5 months? So that's when basically saying t is equal to 5. So the amount is equal to 12,000 times 2 to the 5/3. Okay, get that value. The amount is going to be equal to 38,097.6 people, or you could even round it up to 98. And part C, how long will it take to reach a population of 50,000? So we take the 50,000, put that on the end, because that's what our final population we want it to be. 12,000 still goes here, times 2 to the t divided by 3. Now the idea in this problem is we're going to be solving for t. So divide both sides by 12,000. Now I could get a decimal here, but what I would prefer doing is just keeping it as a fraction. So I get 25 over 6 is going to be equal to 2 to the t divided by 3. Now to get rid of the 2 and bring down the t divided by 3, we're going to have to do log of base 2 to either side. Log of base 2. And basically those two are going to cancel each other out. I'm going to say log of base 2 of 25 over 6 is going to be equal to 3t over 3. And then multiply both sides by 3. Then we can type that whole thing into our calculators. We can get t is equal to 6.177, and I'm rounding to the nearest thousandth, so 3 decimal places. Okay, number 25. Holden purchases a boat for $35,000 in 1997. After 4 years, so in 2001, the boat starts to depreciate at a rate of 8.3% each year. So actually at the year of 2001, how much will the boat be worth in 2012? So it depreciates for a time of 11 years, between 2001 and 2012. That's the important thing to remember here. Do not be fooled by this 1997. So we start off with our amount is going to be equal to 35,000 times, now normally we would do plus, but since it depreciates in value, that means that the value keeps dropping. So instead of doing plus, I'm going to do minus whatever that rate is, 0.083 to the t power. So since the t is now 11, I'm going to place 11 into that problem, plug that whole value into my calculator, and I get $13,000, 493.70 cents. So $13,493.70. When will the boat be worth half its value? So instead of trying to figure out whatever that amount is, we're now going to say it's going to be half of 35,000. So it's going to be 17,500. It's going to be equal to 35,000 times 1 minus 0.083 again to the t power. So this time we're trying to figure out the value for t. So let's evaluate some of this. I'm going to divide both sides by 35,000. And this is actually pretty easy because if you're just cutting in half, it's actually just going to be 0.5 is going to be equal to 0.917 to the t power. And I just evaluate what it was inside that parentheses. Now, to bring down this t, you need to make the log of 0.917 to both sides and do this calculation in your calculator to get the value for t. So t is going to be equal to 7.9995, and we'll round that up to 8. Now, it says, when will the boat be worth half its value? So we know that it's 8 years later, so that could be an acceptable answer. Or you have to make sure that it's 8 years from either 1997 or 2001. And since it started depreciating at 2001, it's 8 years after that. So it's going to be 2009 is going to be your answer. And number 26, to finish up this page. You deposit $4,500 into an account that pays 3.5% interest compounded continuously. Now, yet again, the whole idea of compounding, that's when you use a specific formula, but in this case, we're going to be using PE to the RT. So as we like to say, PERT. So the deposit amount, which was $4,500, the E, which is, well, we can do this in our calculator, the rate, which is 0.035. I'm trying to figure out what the T value is equal to, and it says the tripled amount. So how long will it take to triple that value of 4,500? So if you triple that, 4,500, we end up getting 13,500. Divide both sides by 4500, and we should end up with 3 on the left-hand side. E to the 0.035 t. Calculate ln to both sides. That will drop the 0.035 t, and then divide both sides by 0.035. Now, since these are word problems, you probably don't want to keep this as your answer. You want to convert it to a decimal. So t is going to be equal to 31.389 years. All right, that finishes up page 3. If you guys have any questions, please make sure that you comment down below. Click the link in the top left-hand corner to go to the previous page, or click the link in the top right-hand corner to go on to the next page when it is available. Thanks for watching.